All right, thanks again for having me. So yeah, I'll talk about our electrical engineering senior capstone design projects that we have here. And again, there are similar projects also in mechanical engineering and computer engineering and computer science. Each run differently, but the general idea is somewhat similar. So in terms of our electrical engineering capstone program, we've been running it in its current form for about 5 years. It's an elective sequence taken in the senior year. So it's meant to provide design projects to groups of two to four students that kind of capture a variety of the material that they've learned over the years and that they have to incorporate into the projects. So we have groups of 2 to 4 students. Each group is assigned a technical advisor depending on the particular project that they pick. I'll talk a little bit about more as I describe the projects. Over the course of the year, the students begin again by speccing out the project and coming up with a project plan, a set of design specs, and so forth. That begins beginning of the academic year in October, and as the project progresses, they then shift into sort of more of an execution phase, and then they spend the last 3 months frantically putting everything together and so that they can present it at the end of the year. And so every year in June, which is coming up in a little over a month, we have a big capstone presentation day which is open to the public where the students present what they've worked on during the year. So in the electrical engineering program, we typically run about 4 to 6 projects every year. This year we actually have a large group. We have 7, and I'd say it's probably expected that our numbers will gradually rise over the year as they have been during the last 5 years. We have all the projects that we run projects in a variety of different areas and expertise. And so all the projects are established in advance. So I work with faculty sponsors, research group sponsors on campus, as well as industry partners to establish a variety of projects in a variety of areas in electrical engineering. So that the funding for each of these projects, the projects are generally proposed and at least initially spec'd out by their sponsors, and they provide the funding as well, which is typically on the order of about $6,000 for the year, and that again, all the cost of all the materials and that the students buy and use for the project all comes out of that. That's a gift by the sponsor, so each project group is assigned a technical advisor. So depending on the electrical engineering expertise of the sponsor, sometimes sometimes the mentor will come from the sponsor's particular research group or company, and sometimes I'll work with the sponsors to find somebody who's suitable mentor. The typical projects, and I'll show you some examples of past and current projects, but ideal projects will require sort of knowledge from a variety of areas in electrical engineering. So areas such as we have energy efficiency projects, but we have signal processing. We've had electrochemical cells. We've had photovoltaic applications and so forth. And then also software skills as well. Ideally, the ideal projects incorporate both some hardware and some software components. So think about kind of a project where you use maybe an Arduino or some other microprocessor to control a system and maybe interface with your mobile phone, create a phone app for it. So those types, that's kind of a generic description. And again, these projects also have to be spec'd so that they can be completed in a 9-month period by a group of 2 to 4 electrical engineering undergrads who've probably never worked on anything like this before. So the general course structure is in the fall. We have project selection at the very beginning. So we generally spend I generally spend the summer soliciting projects, and we come to class first day with a list of projects for the students to select. The mentors all get or the potential sponsors all get a chance to come in and present their project ideas to the students. And then during the first week to 2 weeks, the students will form groups and select projects. And after that, the bulk of the fall quarter, I would say, is spent on researching the technology, coming up with a set of design specs and a project plan for completing the project. And then towards the end of the fall quarter, the students sort of begin to transition into actually executing on the project. They'll typically present a prototype demo at the end of the fall quarter or at the beginning of the winter quarter. That was around December, January. And then they'll continue working during the winter and further refining their projects. And typically, if there's a PCB design that needs to be done, that'll get done typically around the end of winter quarter. The students go away for spring break, and hopefully when they come back, the PCB is there and waiting for them. And then they, like I said, they typically will spend most of the spring quarter putting the system together, implementing all the software, debugging, and then they'll present at the in June at the Capstone presentation day. As far as course material goes, we also try to introduce them to things like project management, project planning, Gantt charts, how you go about establishing a good set of design specs. We also introduce them to intellectual property, patents, trademarks, branding, and various topics like that. So they kind of get an introduction to kind of the full spectrum of product design and development. So I think I more or less covered that slide. So I'll show you a few examples of projects that have been done. I selected just a small subset of projects. These are all projects that have been sponsored by industry partners, the ones I'm showing you. And I tried to pick ones that were sort of had an energy efficiency theme to them. So this project right here was sponsored by Morgan Pattison of Solid State Lighting Services. He's a former student of Shuji and Steve's in the materials department, and he does a lot of DOE work on solid state lighting. And he was interested, as anyone who was here for Steve Denbar's talk earlier saw, that LED lights, they don't emit isotropically like standard, like incandescents. They have some sort of an anisotropic component, isotropy to them. And not only is the total output power not perfectly isotropic, but the spectral density is also not perfectly isotropic, which basically means if you look at an LED light from different angles, the color looks a little bit different. And so there isn't really an industry standard for analyzing this aspect of bulbs, and he basically wanted a tool that he could use to basically analyze the spectral intensity as a function of angles. So this was the tool that the students built. It basically is it's a goniospectrophotometer, so you could mount your replacement bulb right here, and it has a big lever arm, collects the light up here and transports it to a spectrophotometer, which isn't shown here. And the whole tool can, the lever arm can move all the way from a 90-degree angle all the way up to viewing the bulb from the very top. And it's interfaced with a MATLAB interface that they created to collect the data and produce nice graphs of the collected data. Another project also sponsored by Solid State Lighting Services was a project it was sort of a modern day version of the clapper. So it's basically a smart plug that you would connect in series with any component, and instead of using your hands and clapping to turn the device on and off, you use your smartphone. It also had dimming functionality and other aspects that they implemented to it. They did proximity sensing, so you could actually build a wireless mesh of these things and use them to locate a user's exact position. And so the group demonstrated this. They also entered the project in the new venture competition here at UCSB and did quite well and founded a company off of it, which recently, a few months back, they concluded a Kickstarter campaign, raised, I think this is from day 6, but I think they raised about $175,000 in pre-orders, which they plan to ship in about a month or 2 last I talked to them. Another project. This was sponsored by Unite to Light, which John Bowers is involved with, and so they create these lights, these solar-powered lights for the developing world. And their first generation was sort of this basic reading lamp with a little solar panel on here. And their second generation of light included a larger panel and also a USB port for charging of cell phones. Which was great for developing regions which are off the grid, but everybody has a cell phone and needs some way to charge it. The way they do it now is they typically pay $4 or $5 a month to somebody with a big generator, and they often have to walk 1 or 2 hours to drop their phone off to charge. But the issue with this is the initial cost is prohibitive in these regions. I mean, even selling something like this for $40 or $50, which would pay for itself over the course of 6 to 7 months in terms of how much they just pay somebody to charge their phone, was prohibitively expensive. So the idea was to come up with a system where you could implement a pay-as-you-go protocol. And they wanted to use existing infrastructure in these regions, which basically meant that there was no electric grid, but everybody has a cell phone. And so basically the solution that they came up with and implemented was they could essentially have a cell phone call a server, enter some kind of a code that they could purchase at a store, same places that you purchase your calling cards, and that server would then provide a code which they then need to transport onto the device to get it to continue to operate. And the way they thought to do that was every device has a speaker output, an audio jack. So they would basically run an audio cable into the light and have a circuit that can basically they used a DTMF circuit that can basically detect audio signals and basically decode a signal that was piped in via audio, and that's how they would enable it. And so they implemented the circuit plus a number of signal LEDs. They actually had to completely redesign the light from scratch because they couldn't actually get the design from the manufacturer. So they completely built this. They used Google Talk to basically create kind of a proxy call server that they could actually call into and grab a code for their phone and enter it into the device, and it worked really well. And they actually filed a patent for the system that they developed, which is currently pending right now. Project that we're running this year with FLIR. This is a great project right here. They called the project the IR Scout. So this is a tool for first responders who maybe approach a scene with kind of a dangerous environment that they don't want to enter right away. And so the tool consists of this sphere with a bunch of FLIR's Lepton infrared cameras that they just released at CES this year. At least they demoed at CES. This group is basically the guinea pigs for for getting these things to work. But they're these tiny little infrared sensors that you can easily fit them, on the back of a phone. And so the idea with this tool is there's 12 of these cameras co-mounted with an RGB camera, and you would toss it into your danger zone, and it stabilizes, and then also includes a sensor package like an accelerometer to detect stabilization, temperature sensors. And once it's stabilized, it basically begins transmitting data wirelessly to currently a computer, but you could also do it on a tablet or a personal device. And that way you could assess the environment before running in. And the obvious advantage of having infrared cameras is if you have a lot of smoke and debris in the area, you can image right through it. So this is actually a joint project that we're running with the mechanical engineers. So there's actually an electrical engineering team and a mechanical engineering team. The electrical engineering team is doing the electrical design, and the mechanical engineering team is doing the mechanical design. It's been a really fun project to work on with. This is the first year we've tried to do these joint projects, and we're definitely open to doing more of them if we get some good ideas and some sponsors who are interested. Again, as an industry sponsor, what you can get out of these projects is obviously if you have an idea that's of interest to you, you can have that completed here at a fairly minimal cost. You get access to university resources. And what I think companies really like to use this for is it's a great way to kind of, you get to train a group of 3 to 4 students for 9 months, and you get to pre-screen them. And then if you want to hire one of them afterwards, then you know exactly what you're getting, and they've already been trained for 9 months. So that's a major added bonus. And these are some of the groups and companies that have sponsored projects over the last few years. So if you're interested in establishing a project, again, you can contact me through, you can look me up, or I have cards if you want them, or you can get my info through Jen in the IEE. And perfect. Even better, then you have my contact information already. So get in touch with me. Like I said, we usually establish these projects mostly over the summer. So around June to early July is a good time to make initial contact with me. And I'll work with you to help spec out the project to ensure that it's suitable for the target group that's going to be working on it. And we typically need to have these projects kind of ready to present to students by about mid-September, so that end of September, beginning October, at the first day of class, we can present these projects to the students and they can begin their selection process. And then the projects are worked on through June of the following year. So that's pretty much everything I have. If there's any questions, I'd be happy to answer them. I'll also stick around a little while later if anybody wants to talk a little bit more.